Right, in this case, we have a block of mass M that is held in equilibrium below a horizontal ceiling by two strings. All right, so the strings are given there. One spring is on has a force of T newtons, the other one has a force of 20 newtons. So those are tensions, by the way. Right, each string has an angle of inclination to the vertical. That's what we have there. All right, so this question wants us to find the value of T and M. All right, for you to deal with this type of a question, again, you have to identify all the forces that are acting on your system. Try to resolve horizontally and resolve vertically. And then after doing that, normally, if you have two variables that you're looking for, you have to form some simultaneous equations in a way. Okay, you have to generate some simultaneous equations. So in this case, I'm just going to draw the forces on the diagram that we have, right? So basically, this is what we have here. Obviously, we have weight, right? Weight is pointing downwards. This is mg. All right, remember in this case, since it's mechanics, g is equal to 10. Can use meters per second squared as the unit, or newtons per kg is still fine. Those are the units for g. But if you're in physics, you know you can use 9,81. All right, these are similar questions, by the way. Right, so we have weight there that's pointing downwards. Then the other forces, they're not really on along the y-axis or the x-axis. So what it means, we need to resolve. Right, so how do we resolve this? We can use the idea of similarity here and stuff. So right, let's have another axis here. So let's assume we have our horizontal axis here. So if you have a horizontal axis here, what it means, that vertical line, that line at the top there, is parallel to this one. So since it's parallel, that means these lines are acting as the tension lines. They're acting as transversal lines. Okay, so this becomes 60 degrees here, and this becomes 45 degrees. So now if you look at the T Newton force in relation to our vertical axis and the horizontal axis, so you can have your horizontal axis, that's x-axis there, then the vertical axis, of course, we assume is here. This is our y-axis there. So if you're looking at this, you can see that the vertical component of T will be T sine 45 degrees. Then the horizontal component in this direction will be T cos 45 degrees. And then for the 20 Newton force, the vertical component is 20 sine 60 degrees. Then the horizontal component, that's 20 cos 60 degrees. So once we have this, that means now we can equate the vertical components and also equate the horizontal components. All right, let's start with the vertical component. So consider the vertical components. Consider the vertical components. Right, so with those two, that's T sine 45 and 20 sine 60. T sine 45 plus 20 sine 60. Right, this is equal to mg. Right, so we know g is 10 there, so that means here we have 10g down there. Sorry, 10m. We have 10m down here. Right, pardon me there, this is supposed to be 10m. So what it means, I'm gonna come here and add my 10m there. Simplifying this, you know, sine 45 is root 2 over 2. So this is root 2 over 2t plus 20 times root 3 over 2 there. This is equal to 10m. Right, just double check, sine 60 should be root 3 over 2. Yes, perfect. Right, simplifying this, getting 10 there, right? Then that means I have multiplying by 2 everything. I have root 2t plus 20 root 3 minus, right, this is equal to 20m. Right, I can bring this guy this side. All right, let me just leave it here. This is equation number 1. Right, then the horizontal components. Now for the horizontal components, we only have those two balancing each other out. So that means we have t cos 45 is equal to 20 cos 60. Right, cos 60 is half. Cos 45 is root 2 over 2. Yes, cos 60 should be 0.5. Okay, so this is root 2 over 2, right, t, right, this is equal to 20 times half, that gives us 10 there. That means we have root 2 over 2t is equal to 10. Multiplying both sides by 2, I have root 2t equals 20. All right, this must be simple simultaneous equations. So now we need to solve these two guys. I'm sure you can see that root 2t is equal to 20, so I can just come here and substitute 20 on that one. All right, and by the way, from there we can simply say t is equal to 20 over root 2, and then that gives us how much? 20 divided by root 2. Root 2, that gives me 14.1 newtons. Super. Then I can just come there and substitute 20 there. So I have 20 plus 20 root 3 equals 20m. That means I'm dividing both sides by 20 by 20. So m is equal to that. Let me simplify that and see what we get there. 20 plus 20 root 3, right, divided by 20. This gives me 2.73 newtons to 3 significant figures. Okay, so this is basically how we deal with this, but you can always space out your work and make sure that everything is set. But the general idea is to identify all the forces acting on that system, and then you try to resolve the forces that are not perpendicular or parallel to the planes that you're given. Then you can equate them and form simultaneous equations. Thank you so much for watching, guys, today. See you next time.